this total part, whatever is there, up to this total part, whatever is there, this total part will be called actually larynx. Total part will be called larynx actually. And in this larynx, what will be there generally in the larynx? Actually, that picture was not there in this particular slide. So, larynx will have a windpipe, two vocal cords will be there, and muscles attached to the vocal cords. All these things will be there in the larynx actually. So, larynx consists of all these things. Windpipe will be there, two vocal cords will be there, and muscles also will be there. So all these things will be there in the larynx, and the main part by which we can hear is larynx only, but it is not mentioned here. So total part will be called larynx. Okay. Right. Now you have to understand about some parameters related to this particular sound, and to understand about few parameters related to the sound. Let me ask you a few questions here. So can you hear all the sounds?
No, sir.
Sounds?
No, sir.
Right, Ronak, you are giving answer.
Yes, sir.
Right, so you give other chance. Alex. Alex,
Yes, sir.
tell me, can we hear all the sounds?
No, sir.
So which type of sounds we can hear?
So there is a degree to which we can hear.
Degree will be there. Okay.
Second.
Right, tell me again, can we hear all the sounds or not?
No, sir.
No, sir.
Right. So we can't hear all the sounds. So we can hear only few sounds actually. And whatever the sounds which are audible for you, which you can listen, those sounds will be called actually
Audible sounds.
audible sounds. Those are called what? Sorry.
Audible sounds.
Those are called audible sounds. And whatever the audible sounds are there, their frequency generally, what do you mean by frequency? And what do you mean by amplitude? What is the time period? All those things we are going to learn now. But first you have to understand about audible sounds. The frequency of the audible sound generally will be in between
20 up to 22,000 hertz.
20,000 hertz. What is the frequency of the audible sounds? 20 hertz to 20,000 hertz. So that sound can be heard by our ear actually. So we can't listen the sounds which are having frequency less than 20 hertz, frequency greater than the 20,000 hertz. So we can't listen them. We can listen only the sounds which are having frequency in between 20 hertz to 20,000 hertz. And whatever the sounds which are having frequency less than 20 hertz, those particular sounds will be called infrasonics. What they will be called?
Infrasonics.
And whatever the sounds which are
ultrasonics,
greater than 20,000 hertz, those particular sounds will be called ultrasonics actually. So now try to understand here. The sounds which are having frequency in between 20 Hz to 20,000 Hz are called audible sounds, which our ear can recognize. And the sounds which are having frequency less than 20 Hz, those will be called infrasonics, which can't be detected by our ear. And the sounds which are having frequency greater than 20,000 Hz, Those are called ultrasonics, and these two can't be detected by our ear actually. And do you know where these infrasonics can be produced? Infrasonics can be produced in a generally earthquake. And whenever earthquake comes, whatever the sounds which are produced will be infrasonic. That means lesser than the 20 hertz. So we can't recognize those sounds. And few animals are there which can recognize these sounds. Those are
Sir,
nothing.
like elephants.
Huh?
Sir, elephants.
Elephant.
Yes, sir.
Okay, so few animals can recognize it. Among them, the particular one is dog. Dog can recognize infrasonics, and maybe you know that in Japan, one of the country which in which at least for a month 3 or 4 times earthquake comes, and there they can recognize whether earthquake comes or not by using their pet dogs. And when earthquakes are coming, those pet dogs will behave in a particular manner as they can listen these sounds. So the sounds which are produced in the case of earthquake will have frequency lesser than the 20 hertz, and those are called what? Infrasonics actually. And the next one, the sounds which are having greater frequency than the 20,000 hertz are called
Ultrasonic.
and these ultrasonics, whatever sound waves are there, those can be produced by few animals like bats. Maybe you know that bats, you know about that animal, bats animal,
Yes, sir.
right? So that bats can able to produce ultrasonics actually. And even dogs also can produce ultrasonic sound waves. And sometimes if you see, the mouth of that particular dog will be opened and you can't listen something. You can't listen the sounds which are produced by the dog. Why? Because at that time they releases ultrasonics. And maybe you know that ultrasonics can't be recognized by our ear. So this is about the frequency of the sound which can be audible for us. Now again tell me, which type of sound waves we can hear?
Sir, may I?
Others, which type of sound waves we can hear? Kavya, are you there?
Yes, sir. We can hear infrasonic sound waves.
We can hear infrasonics.
So we can hear audible sounds.
Right, we can hear only audible sounds which are having frequency in between 20 hertz to 20,000 hertz. Other than that, our ear cannot recognize anything. Okay, now if you are listening any sound, definitely it will be in between 20 hertz to 20,000 hertz. And if you are not listening it, either it may be infrasonics or it may be ultrasonics. But here you have to understand about amplitude, time period, frequency. So I said here frequency. But to understand about this frequency, first you have to understand about amplitude. And to understand about amplitude, again tell me, generally sound will be recognized through the vibrations, and already you know that our eardrum will perceive those vibrations and that will be amplified and it will be given to our brain, and so that you can listen. But here first you have to understand, whenever sound wave is traveling through the medium, definitely energy will be given to the particle of that medium, and when energy is given to the particle of the medium, it will vibrate actually. Vibrate means it will move to and fro from this particular position. Now this is central position. First it moves to the right side, and after that it comes to the left side again, and it reaches to this point again and again comes back. So like that it will move to and fro. And this type of motion generally will be called oscillatory motion. Tell me last.
Sir, 4 types: rectilinear, circulatory, Sir, oscillatory. Sir, and the fourth one. The fourth one, I don't.
Okay. So let me say actually three types only will be there, and those three types are: first type of motion is called translatory motion, and second type of a motion is called rotatory motion, and third type of a motion is called oscillatory or vibratory motion. What it is called? Rotatory. Sorry, what is the third one? Oscillatory or vibratory motion. So three types of motion will be there. Among them, which type of motion will be there for a sound? Vibratory motion or oscillatory motion will be there. What do you mean by oscillatory? Means moving to and fro from a mean position. And to understand about this, let me give one best example in our daily life. Maybe that will be nothing but the pendulum which will be there in a clock. And have you seen old clocks? Have you seen old clocks which will have a pendulum like this?
Yes, sir. They're called grandfather clock.
Right. So pendulum will be there like this. And if you drag pendulum to one of the end, and if you release from here, it will move to this side. And again it comes back and reaches to this point again. So like that it goes on moving right side and left side to a fixed point. This is called mean position actually, and to the mean position to and fro. To and fro means right and left side it will have a motion, and this type of a motion will be called oscillatory or vibratory motion. And in this vibratory motion, generally you have to learn about a few parameters like this. First one is about amplitude, second one is about time period, next one is about frequency. So first we are going to learn about amplitude. And what we mean by amplitude, just now I said this is mean position, central position. And from this central or mean position, how much maximum distance that particular vibrating thing can move will be known as
Amplitude.
This is called actually amplitude. So see here, the maximum distance to which the bob of a vibrating pendulum goes from central position is called amplitude of vibration. So here he has taken this example to understand. But suppose if I say one particle is there, one molecular particle is there, so that particle is there at a mean position here, but when it is vibrating, it is maximum displacing up to this distance. Suppose from here to here, 3 centimeter distance is there. Maximum distance is 3 centimeter. Then what will be the amplitude? 3
3
centimeter.
centimeter.
So that means what? The maximum distance a vibrating body can move from a mean position to any one of the side. It may not be particularly to the right side or left side. So the maximum distance which it can cover to any one of the side from a central position or mean position, that will be called actually what? Amplitude. And remember, wherever vibratory motion will be there, definitely what term will be there?
Amplitude.
Term will be there. So you have to understand this. Have you got my point, Alex, Kavya, Naisha, Veda?
Yes, sir.
Sir,
Ronak?
yes, sir. Sir, can we call amplitude as a maximum displacement?
Maximum displacement. Why needed? It is distance only, no? Here, displacement also you can say. But here, as we are speaking about a distance, sometimes it may be about a rotatory motion also. So that's why we will not use that particular term called displacement. Okay?
Okay, sir.
Right. All others, is it clear? What is an amplitude?
Yes, sir.
Right. Kavya, can you say definition for it? Not in the case of pendulum, in general case.
The amplitude is the maximum distance on to which a particular object goes from its main position to it is a it's a maximum distance to which an object goes to from a main position.
Right. So you have to say like this, the maximum distance traveled by a vibrating body is known as what? Amplitude. It may be to any side. So that's why you should not specify any direction. Okay. So what is the unit of amplitude? The unit of amplitude may be in centimeter or it may be in meters also sometime. Okay. As it tells us about distance only. So whatever the units are there for a distance, same unit will be there for a amplitude. Okay.